Dear friends, this is an introductory lecture on energy audit of boilers, and this is a very interesting aspect. Boilers, they are the most energy intensive thermal utilities in any industry, and as energy auditors we would be interested in reducing the fuel consumption of boilers. So before attempting to reduce the fuel consumption of boilers or steam generators, we need to understand the methods for performance evaluation of those boilers. So the objective of this short video is to develop our capabilities to use the two methods for boiler audit. One is the direct method for boiler audit, and the second is called as the indirect method. So we'll be discussing both these methods in this video, and we will be trying to understand the significance of both the methods, the advantages of each, and when they should be used in what particular context. So this is the objective of this lecture. So you know that steam generators or boilers, they are widely used in industry, and generally we find in process industries what is known as for example, process industry means, let us say some example of sugarcane industry, okay, value sugar industry, or let us say some plant like your rubber industry. You'll find that process boilers are used. Many companies are into this boiler business. For example, Thermax is a major supplier of boilers, and when such boilers are used in industry for process heating means for generating steam, and the steam is used for further application. For example, steam is used in the sugar industry for converting the sugarcane juice to sugar crystals, or in the rubber industry for making tires, curing the tires and tubes. That is, or in the pharma industry, which is an important application of boilers. So there, if we are able to improve the efficiency of those boilers, your fuel consumption, the energy bill would be reduced. Similarly, if you are talking about power plants, there too, if you improve the boiler efficiency, the coal consumption would be reduced. How do we determine the efficiency of the boiler? That comes before we go and intervene in improving the efficiency. So the methods, there are two methods as I said. One is the direct method, and let me tell you what it is. So the direct method, as the name indicates, direct method of boiler efficiency, we need to use the first law of thermodynamics for getting this expression for direct method. So boilers or steam generators, if you talk about, it's an open system, where water gets in and steam comes out. This is the mass flow. So from the mass flow angle, you'll find that, and neglecting the makeup water, you'll find that if MW is the water which is supplied and MS is the steam which is generated, or the flow rate of water which is supplied to the boiler is, let us say, m dot W, and if the flow rate of the steam which is generated by the boiler is m dot S, then neglecting the makeup water, we can say that m dot W is equal to m dot S. So this is the mass balance for the boiler, okay, and this is useful while we determine the efficiency of the boiler using direct method. So for the same boiler now, if I write the energy balance, okay, so the boiler, you get steam which is having certain energy output, okay. So this is the output of the boiler in terms of energy. In terms of mass, the output of the boiler is steam. In terms of energy, the output of the boiler is the energy associated with the steam. So the rate of energy associated with the steam is the output of the boiler, and if you want to find the net output, then we need to subtract the energy which is associated with the water which is entering the boiler. So it means that in terms of energy, the output of the boiler is what? The output of the boiler is the energy which is associated with the steam, which is nothing but the enthalpy of the steam, minus the energy which is associated with the water, which is nothing but the enthalpy of water, right? Multiplied by the mass flow rate of the steam, which is same as the mass flow rate of the water, So the steam generator output is Hs minus Hw into m dot s, where Hs is what? Hs is the enthalpy of the steam. It is the enthalpy of the steam, and Hw is the enthalpy of the feed water. Hw is the enthalpy of the feed water. Okay, feed water. Feed water is the water which is fed to the boiler. This is the output of the boiler. Now, what is the input to the boiler? Okay, what is the input to the boiler? So you know that suppose we take a case of coal-fired boiler, or for coal-fired boiler, then in terms of mass, what is supplied is coal is being supplied. Okay, coal is being supplied means coal is being burned in the furnace of the boiler. Okay, in terms of energy, what it is? It is the energy which is liberated by combustion of the coal. It means that if you want to know the input of the boiler in terms of energy, it is equal to the energy which is liberated by the combustion of the fuel. Okay, and hence your input expression becomes a very simple expression. Input expression becomes the fuel consumption rate, that is the fuel. In this case, let us say coal was the fuel. If it is an oil-fired boiler, oil is the fuel. And if I put a dot over it, it means that it is a fuel consumption rate. So the fuel consumption rate, m dot f, into the calorific value of the fuel, Cv, calorific value of the fuel, that becomes the input, right? So once I have stated what is the input and output of the boiler, so the direct method of boiler efficiency is the ratio of energy output upon energy input. So straight away we calculate what is the energy output of the boiler divided by the energy input to the boiler. So once again I will write the expression. So that becomes a formula or expression or the mathematical model for finding the boiler efficiency by direct method. So what is the output we said? Output is, we said, it is a steam generation rate, and mind well, steam generation rate is equal to the water consumption rate, okay, neglecting the makeup water. M dot S into enthalpy of the steam minus enthalpy of the feed water. This is the energy output of the boiler, and input, as I said, it is equal to the fuel consumption rate, m dot f into the calorific value, okay. So that gives me the boiler efficiency, by direct method. So whatever I have written here on this slide is the boiler efficiency expression by direct method. And you look at this, if you want to determine, if you are taken to an industry where there is a boiler and you are asked to determine what is the efficiency of that boiler in that industry, so what observations you will take? Look at the expression. So you would be interested in knowing how much fuel that boiler is consuming. Okay, so you would be taking the reading of the fuel consumption rate of that boiler. So when you go and visit the boiler, and if you are asked to determine the boiler efficiency by direct method, you would be interested in knowing what is the fuel consumption rate, let us say per unit time. Okay, and you would be interested in knowing what is the water which is consumed by the boiler, or how much is the steam generation rate. what is the water which is consumed by the boiler per unit time. The unit of the time has to be the same in the numerator and denominator. So what is the water which is consumed by the boiler per unit time, that we would be interested in knowing, right? Then you need to do the analysis of the fuel and you need to get its calorific value. So this is also we should do if I want to get the boiler efficiency, right? So now if I am to determine the boiler efficiency by direct method, I would be taking the readings of fuel consumption, I would be taking the readings of either the water consumption or the steam generation rate of the boiler. What else I would require? So I would be required to find the enthalpy of the feed water. Now how do we find the enthalpy of the feed water? From the steam tables, you can find the enthalpy of the feed water by knowing the temperature of that water. So you need a thermometer or thermocouple which would measure the temperature which is of the water entering the boiler. Okay, so use a thermometer or use a thermocouple which gives you the temperature of the water entering this boiler. And what else you would require is you would require to note down the boiler pressure as well as the temperature of the steam which is generated. Okay, so if you note down the boiler pressure and the temperature of the steam which is generated by the boiler, then you can find the enthalpy of the steam from the steam tables. Okay, so it becomes very easy now that if you want to determine the boiler efficiency by direct method, your job becomes pretty simple. You need to take the fuel consumption reading, you need to take the water consumption reading or steam generation reading, you need to measure the temperature of the water, you need to measure the pressure and temperature of the steam. Only these few readings will help you calculate the boiler efficiency. And this is the advantage of the direct method of boiler efficiency. Okay, so what is the advantage of determination of boiler efficiency by direct method? The advantage is that you can get the boiler efficiency by very few readings. Okay, you don't require to go into the details of that. Okay, so that advantage becomes a disadvantage when we are talking about the boiler audit. Why is that a disadvantage? What is the advantage? I said the advantage is that it's simple, and the disadvantage is what? The disadvantage is that because you simply know the efficiency and you don't know where the losses are happening. Okay, where are the losses happening? Let us say that you get some efficiency of 80%. If 80%, which is the efficiency by direct method. So what you know is that 20% are the losses. So from the direct method, if I find an efficiency which is equal to 80%, you can at the most say that the 20% are the losses, but you don't know where these losses are happening and why is the efficiency so low. Okay, so in order to know where the losses are happening and in order to do a intervention to improve the energy conservation of the boilers, you need to pinpoint the losses, find the losses where they are happening, and then calculate the efficiency. So that method where you find the losses and then calculate the efficiency is known as the indirect method. Okay, so the indirect method, a very useful method for calculation of boiler efficiency, is what? The efficiency you calculate as 100% minus loss 1% plus loss 2% plus loss 3%, so on. Whatever are the losses, you find the percentage losses. Okay, add them up and subtract it by 100%. So that gives you the efficiency of the boiler by indirect method. Now what exactly is done? How do you calculate the losses and what are the losses in the boiler? So that understanding is a bit involved in understanding. Okay, but I'll touch upon that when we solve the numericals. Okay, we would be understanding it more properly. Okay, so what are the losses in the boiler? So one of the, now as I said, the expression of efficiency is 100 minus the summation of loss percent. Okay, L1% plus L2% and so on. Okay, now this L1, for example, is an important loss. Okay, L1, L2, whatever you name it. One loss is the losses which are happening in the boiler via the flue gases, via the dry flue gases. Flue gases means what? Flue gases means the products of combustion. Okay, you know that boiler, you are burning a fossil fuel, and this, when you are burning a fossil fuel in presence of air, you get what is known as the flue gases, products of combustion. So these flue gases, they are at certain temperature, Tg, let us say, and because they are at a temperature which is higher than the ambient temperature, so they would be losing certain energy in the form of sensible heat. So how do you calculate that losses? So for example, if I want to calculate L1%, so it would be mass of the flue gases, because it is a sensible heat loss. Okay, that is the heat loss by virtue of the temperature. So mass flow rate of the flue gases into the specific heat of the flue gases. This is specific heat of the flue gases, and as I said, it is a sensible heat loss. It means that the temperature difference, temperature of the flue gases, or Tg or Tfg, whatever you like, minus the ambient temperature upon mf into Cv. So this expression, okay, this expression, let me write this first. Let me erase this. Okay. So in the denominator, you have mf into m dot f into Cv. So this expression L1 dash is what? It is the percentage heat loss via the flue gases, via the dry flue gases. Okay. Now, there are other components also. Suppose this is L1 dash. Similarly, there would be heat losses. L2, let us say L2, and let us say that it is because of some moisture which is present in the fuel. So there would be some moisture present in the fuel, and that moisture would be evaporating. Okay, so when this moisture is evaporating, that is going to take away certain energy. So we can say that, let us say there is some loss because of that. And how is that to be calculated? So for that, we need to know what is the mass of the moisture. Let us say mW is the mass of the moisture, into we need to know the latent heat of evaporation. Okay, upon the energy of the fuel, because everywhere, see, I am not calculating L1, L2, L3, I am calculating L2 dash percentage. Okay, so in the denominator it would be mf into Cv. Okay, so this is the latent heat of evaporation. So you'll find that there are a number of losses. Okay, and I'm not going to discuss those losses in detail. Okay, one is, as I said, the major loss, as I said, is heat lost via the flue gases, via dry flue gases. DFG means dry flue gases. L2 is heat lost because of moisture in the fuel, which gets evaporated. L3 could be heat lost because of, let us say, hydrogen in the fuel, which gets converted to water, and then water is evaporated. L4 is, let us say, the surface losses. The boiler is at boiler surface is at high temperature, and the skin losses or surface losses would contribute, right? So on. Okay, so what we do is that I'm just explaining the method, and the detailed calculation of the losses we will take in some other video. Okay, so what we do is that in this case we find this losses in terms of percentage of the energy in the fuel, and then once you compute this percentage, L1 percentage, L2 percentage, and like this, we add up those. If it is ash in the fuel, the ash would also contribute to the losses, like this. So all this has to be added. Okay, so what we have got in this bracket is the percentage loss. And what is the input in terms of percentage? Input in terms of percentage is the 100%. Okay, which is the energy input in terms of because of the combustion of the fuel. So that percentage losses, if you subtract it from 100, you will get the boiler efficiency. And this is the boiler efficiency by indirect method. This is the boiler efficiency by indirect method. Now, what is the advantage of this over the earlier method? As I'm trying to explain you, this indirect method is the boiler efficiency is calculated by first calculating the losses L1, L2, L3, L4. Now, let us say that the same example we are getting 80%. Okay, because the losses are the efficiency is going to remain the same for the same boiler under the same situation. So we had got 80%, and now let us say from this analysis to find that this is contributing to, let us say, 12%. This is contributing to, let us say, 3%, so 15. Okay, let us say this is contributing to some 4%, and this is contributing to 15, 19. Okay, 1%. Okay, so from this now you get an idea that where exactly these losses are happening. So you see that, okay, this is the place where you are getting maximum loss. So can I do something to reduce this loss and improve the efficiency? Or this is the place where this is a major loss. Okay, and can I neglect this? Can I stop intervening in this L4 dash? Okay, like this. So once you get some specific numbers about the losses, you can take a decision as an energy auditor what measures we should take to improve the efficiency of the boiler. Okay, so this is the advantage of the boiler efficiency calculations by indirect method. So energy auditors generally, when they are doing a detailed audit, they would not calculate the boiler efficiency by the direct method. They would compute the losses, calculate those losses in terms of percentage input of the fuel, that is L1%, L2%, like this, and then subtract that percentage losses from 100% and arrive at the boiler efficiency. Once they have computed the losses, okay, then they would suggest to the company, to the industry, what measures we should take so as to improve the efficiency, right? So these were the two methods. The outcome obviously is that you have now understood. There's an elementary understanding, I would say. You have understood. Let me just figure it out. Outcome is we have, what is outcome? We have understood when to use the direct method, for elementary calculations. We have understood what is the advantage of that method. What is the advantage of this method? The advantage is that it is simple to compute. And what is the disadvantage of this method? The disadvantage is that it is not able to what? Tell you exactly where the losses are happening. And then we had seen, what did we see? How to calculate the boiler efficiency by direct method. Okay, in few other videos we will take some concrete examples, okay, and understand this concept more clearly. Okay, so thank you one and all. I hope you understood this.